They're simple, convenient, and pretty much ubiquitous in bathrooms around the world. But have you ever stopped to wonder how soap bottle pumps actually work? These clever devices manage to create suction inside the bottle to draw up liquid soap without any electricity or moving parts. In this video, we'll be taking an in-depth look at the inner workings of a soap dispenser pump to find out just how these ingenious little mechanisms work. We'll examine the basic components, see how they fit together, and learn about the science that makes everything work so smoothly. By the end, you'll have a deep understanding of how soap pumps work and why sometimes they can fail. Let's get started. Number 1. Anatomy of a soap pump. To understand how a soap pump works, first let's familiarize ourselves with the main components. Here is a diagram of the key parts. First, we have the pump head, also known as the actuator. This is the part you press down on to dispense soap. It often includes a locking mechanism to keep the pump from accidentally dispensing soap when the bottle is traveling. Inside the pump head is a spring and a hollow chamber connected to a narrow tube called the dip tube. The dip tube is long enough to reach the bottom of the soap bottle. When you press the pump, the piston slides up and down inside the chamber, forcing the liquid in the dip tube to move. At the top of the dip tube inside the bottle, there's a one-way valve that allows liquid to flow upwards, but not back down. This prevents air from entering the tube. As the liquid moves upwards, it exits the pump through a small opening called the nozzle. The nozzle controls the flow rate of the soap. Some pumps have an adjustable nozzle for more control. Now let's take a closer look at each part and how they interact. The pump head contains the mechanism that converts your downward force into suction to draw up the soap. The spring provides the force necessary to draw liquid up the dip tube. When the spring is compressed, it creates suction on the return stroke. The piston slides back up, allowing more liquid to be drawn up the dip tube. The chamber simply acts as a holding space for the liquid before it is pushed out through the nozzle. The dip tube is responsible for transporting the liquid from the bottom of the bottle to the pump mechanism. The valve at the top of the dip tube makes sure the liquid only flows upwards and doesn't back up into the bottle. The nozzle controls how fast the liquid flows out of the pump. Some nozzles are adjustable. 2. How a soap pump works. A step-by-step guide. So now that we understand the basic anatomy, let's see how it all comes together. Here's a step-by-step explanation of the process. Step 1. Pressing the pump head. When you press the pump, you compress the spring, forcing the piston against the liquid in the dip tube. This pushes the liquid up and out of the nozzle. Step 2. Creating suction. As it rises, it creates a partial vacuum, or suction, which pulls more liquid up through the dip tube via the mechanism of atmospheric pressure. Step 3. One-way valve action. The one-way valve at the top of the dip tube only opens in an upward direction. This ensures that the liquid flows upwards into the pump and doesn't leak back down into the bottle. The liquid exits the pump through the nozzle, either as a stream for thicker liquids like hand sanitizer, or as a foam for soap. 3. Foam pump Vs. Liquid pump. Key differences. Some dispensers pump liquid, while others are designed to dispense foam. How do foam pumps differ from liquid pumps? Let's take a closer look. First, we have the liquid pump, which we already studied in detail. Liquid pumps dispense soap or lotion directly from the bottle without any air added. They feature a simple opening at the top of the pump where the liquid flows out. Next, we have the foam pump. These pumps mix air with the soap to create foam. As the liquid flows upward into the pump, air is sucked in through a secondary valve located near the bottom of the pump. This combines with the soap and forces the mixture up through a mesh screen located in the pump head. The screen breaks up the mixture into foam, which is then dispensed through the nozzle. 4. Common soap pump problems and fixes. Soap pumps are fairly reliable, but problems can occur. Let's review some common issues and easy fixes. Problem No. 1. Pump stops dispensing. The nozzle may be clogged with dried soap or gunk. To fix this, rinse the pump under warm water for a few minutes. You can also try using a thin pin to clear any blockage in the nozzle. Problem No. 2. Leaking from the sides. If liquid starts leaking from the sides of the pump, the seals may be worn out or the housing could be cracked. To fix this, replace the entire pump assembly or carefully remove the seals and apply silicone grease around the edges. Be sure to test it well to avoid messy leaks. Problem No. 3. Weak or inconsistent flow. If the liquid flow is weak or inconsistent, air may be trapped in the dip tube, preventing the pump from drawing up liquid properly. To fix this, prime the pump by pressing it firmly a few times to force out any trapped air. Most pumps will prime themselves after a few uses, but you can manually prime them as needed. 5. Evolution of soap dispensers. Manual pumps are the most common type of soap dispenser, but other systems exist. Let's quickly review some alternatives. Automatic sensors. These pumps use infrared motion detection to automatically dispense soap when hands are detected. Are commonly seen in public restrooms. Bag-and-box systems. These are large-capacity dispensers used primarily in commercial settings. The soap is held in a bag within a box. A pump draws the soap from the bag and dispenses it through a nozzle. These are efficient for high-traffic areas. 6. The science behind pump efficiency. There are some interesting engineering details worth noting that make these pumps so efficient. Flow rate. The amount of liquid dispensed per pump is typically between 1 and 3 milliliters. This provides a good balance between hygiene and efficiency. Too little might not effectively clean hands, while too much could waste soap and create mess. This means the pressure you apply to the piston is transmitted equally to the liquid in the dip tube, allowing the pump to easily draw up the liquid. Material choices. The parts of the pump in contact with the liquid are typically made of PP, a type of polypropylene plastic. This material is durable, resistant to most chemicals, and easy to manufacture with. 7. Final thoughts. So now you know how the seemingly simple act of pumping soap involves a delicate balance of fluid dynamics, mechanical springs, and cleverly designed valves. These tiny mechanisms are a marvel of microengineering. So the next time you wash your hands, take a moment to appreciate the precision and ingenuity that goes into every press of that little pump. Speaking of ingenuity, if you enjoyed this video, be sure to show your support. And let us know in the comments with your ideas for topics we should cover in the future. Thanks for watching.